بسم الله الرحمن الرحيم، والصلاة والسلام على أشرف الأنبياء والمرسلين نبينا محمد وعلى آله وصحبه أجمعين. السلام عليكم ورحمة الله وبركاته. In this session, inshallah, we are going to talk about chapter 9, which is Firewalls and Intrusion Prevention Systems. We talked in the last chapter, in chapter 8, about intrusion detection systems, and we will see in this chapter what is the difference between the IDS and IPS, and what complementary that IPS has at the top of the IDS. First of all, let's talk about firewalls. Firewalls, from their name, if you think about firewalls in the war terminologies, it is like the front line of defense. So as the use of the internet is increasing more and more from day to day, it is not as what the situation was 30 or 40 years ago, that only the use of the computer is within the computer itself, and then it expanded to be within a LAN, local area networks. Now almost every device that we are dealing with, such as the PCs, smartphones, tablets, phablets, and other devices that they have the connectivity with the internet. So there has to be a way to filter, to control the stream of the packets of the connectivity from inside to outside and from outside to inside. So the firewall is like a single choke point that imposes security and auditing. It insulates the internal systems from the external. So any coming and even going transactions from outside to our network or computer, and from our network or computer to the internet, should be filtered. Okay, so the design goals of the firewalls that all traffic from inside to outside and vice versa, from inside to outside and from the outside to inside, must pass through the firewall. What is going to happen while passing through the firewall? It will allow only the authorized traffic to pass. Okay, so it is similar to the immune system of the body. Okay, so based on what the firewall will allow or reject the traffic or transaction, digital transaction. So based on firewall access policy. So the firewall access policy is a critical component in the planning and implementation of the firewall to specify what is authorized and what is unauthorized to pass by. Okay, so the firewall access policy will list the types of traffic to be allowed, to be permitted to pass through it, and those that otherwise. Okay, this may include the address ranges from this IP, for example, to this IP should be allowed only to send a transaction or a traffic to our system, and others are not, specific protocols, specific applications, and so on. So it is very important to build and create this firewall access policy based on the organization's information security risk assessment and policy. It shouldn't be created by itself as a standalone. It should be based on the security risk assessment of the organization. So they should be in line with each other. There are different characteristics for firewall filtering that should be included in the firewall access policy, such as IP address and protocol values, application protocol, user identity, and network activity. For example, the IP address, as we said, that for example a range of IP addresses or specific one or a number of IP addresses that should be allowed to pass by. So it is based on the packet filtering here that we will see now. The application protocol, it is called application level gateway, and thereby it specific applications or application category can be stated or listed to be allowed or not. User identity, it is to have sort of user authentication, so specific users who have the authority, the, the authorization to access the system should be authenticated and verified whether to have the possibility or the authorization to access and so allowed or not. Network activity controlled access based on consideration such as the time or request, rate of requests, or other activity patterns. For example, if the size of a specific message or email or application or file exceeds so and so of gigabyte or any other size, it should be not allowed, and so on. The capabilities of the firewalls that it is good to be designed and defined as a single choke point. It provides monitoring for security events. It is kind of convenient for several internet functions, as we stated, the application, the network, the transport levels, and so on. It can be considered as IP security, IPsec, but it has its own limitations, such as it cannot protect against attack by passing the firewall, may not protect fully against internal threats because it is like the borders from outside to inside and from inside to outside. So within the same computer or within the same local area network, it is not functioning for that. It doesn't serve. Bring your own device. Bring your own device. I think that we have mentioned them in one of the classes. We said biode for this one. For this one, we said about biode. BYOD. Bring your own device, which is one of the issues that needs to be considered recently, as usually many organizations allows their employees to bring their own devices like laptops or tablets or even smartphones now, their own personal ones, and then they can access the internal network thereby them. So in this case, the firewall, if let's say my laptop is infected from outside the college, for example, and I bring it to the college while it is infected, I directly connected it to the internal network. So the virus or worm that infects my laptop may spread on the internal network. It will not pass through the firewall as it will be considered internal. Okay, these are the different types of the firewalls. We have the packet filtering firewall, we have stateful inspection firewall, application proxy firewall, circuit proxy firewall. We are going to mention some of their important details, but not all of them. The packet filtering, from its title, that it filters the packets themselves. So the packets usually may include source IP address, destination IP address, source and destination transport level address, IP protocol field, interface, and so on. So it may carry two policies, either discard or forward. Discard means that prohibit unless expressly permitted. The other one, permit unless expressly prohibit. The first one, this one, discard, it will not allow, it will prohibit, it will reject everything. Reject, okay, unless, reject all except A, B, C, what is listed. Okay, so as you can see that the default is to reject all, to reject everything except those that are in our list. Okay, so this is the discard policy. The other one, the forward, is the opposite, is permit, allow, yeah, allow, accept, accept, A, B, C, that those that are listed not to be allowed as like a blacklist. Okay, so we can infer here that in the discard one, it is more restricted, it is more conservative, controlled, as the default is to reject. But the other one consider the usability, the user convenience more than the security. So it is less secure and less restricted. Okay. So the generally the advantages of packet filter is the simplicity and the transparency to the user and the speed even as it is a bit fast. But the weakness is that it cannot prevent attacks that employ application specific, as it considers mainly on the packets or the IPs. Okay, it doesn't support advanced user authentication, just the ordinary one, the simple user authentication. Okay, so improper configuration can lead to intrusions, can lead to breaches if it is not configured well. The other type of firewall is stateful inspection firewall. It it is based on the rules for TCP traffic to create a directory, and based on that directly the traffic will be allowed or rejected. The application level, from its title, it is considered as an application proxy, and it cares mainly about the applications themselves, whether to allow specific applications or not to pass through it. Okay, so it tends to be more secure than packet filters. But the disadvantage is the additional processing overhead of on each connection. Okay, so regarding the other one, the fourth type is the circuit level gateway. Circuit level gateway, from its title, it is like a circuit. So it has two TCP connections, one between itself and a TCP user on an inner host and one on an outside host. We have another type of it that is called host based firewalls that is used to secure an individual host. So it is available in an operating system or can be provided as an add-on package. Its common location is the server. Personal firewall, and from its name again that it controls the traffic between a PC and the internet. So it is not on the network, it is not between the local area network and the internet, but rather it is in our own computers or our own personal computer, between the internet and our own personal computer. Usually it can be implemented on home PCs, personal PCs, and even on the organizations, in addition to the other types that are put on the server to be between the local internet networks and the internet. And in addition, there is another layer that is on the personal computer. These are the topologies. We have done with firewalls. I think that what we have talked about is enough for the time being and in the current circumstances. Let's move to the intrusion prevention systems. Intrusion prevention systems. It can also be called intrusion detection and prevention systems because it does include the IDS that we talked about in the last chapter. So it is an extension of an IDS that includes the capability to attempt to block first. So the main goal first, the main initial goal is to attempt to block, prevent the malicious activities, and if that is not possible, to detect it at a later stage. It is the same as IDS. It can be host-based, network-based, and distributed hybrid. Okay, and the same as IDS, it can use anomaly detection analysis or the signature heuristic detection analysis. For the anomaly detection, to identify the behavior that is not that of the legitimate user, that deviates from the behavior of the legitimate user. But the signature heuristic detection is to identify the known malicious behavior or attacks. They can be blocked as the firewall does. Okay, but the use of the types of algorithm developed by IDS will determine which should be blocked and which should be analyzed, and based on that there will be a decision to later on to respond to it by blocking again or doing other actions. We don't want to repeat what we said on hits in host-based IDS. In HIPS, it is a similar thing. It will be implemented on the host itself. It can be signature based or anomaly based. These are some examples of the types of malicious behavior addressed by HIPS, host-based intrusion prevention system. It will block the modification of system resources, privilege escalation, exploits, buffer overflow, exploits that will lead to denial of service, access to an email contact list, and so on. Let's do some jumping here in order to summarize. And you know what to do if I jump something. So the other one is the network based IPS, network based intrusion prevention systems. It is the same as NITS in IDS. It is on the network. Let's talk here about the methods used to identify malicious packets: pattern matching, stateful matching, protocol anomaly, traffic anomaly, and statistical anomaly. The same things. This is a vendor specific system that, as usual, we are not going to talk about it. Snort here, Snort Inline. You may remember in the last chapter we talked about Snort, that it is a lightweight host-based intrusion detection system. Here it is an advanced one. It is called Snort Inline, that include both prevention and detection. It has three different, let's say, actions to do: a drop, reject, or S drop. They are listed here. The differences between them is slight, is minor, not that big. Snort reject, the drop, for example, rejects a packet and log it. But reject is reject a packet and send and log it again and send an error message in return. So in drop, just reject and log. In reject, log, and send an error message. But in S drop is packet, the packet is rejected without any logging and without an error message. It is useful for honeypot implementation. You can implement it and include it with the honeypot, that lure away the attacker. If you remember from last chapter, you can implement Snort Inline. So you can just reject or drop the access requests, but you don't let the attacker know why the traffic has been dropped or why he is not able to access the honeypot, which he thought that it is the real system. And you you have a precautionary action by not letting the attacker access even the honeypot directly, especially if it is a high interaction honeypot. And while doing so, you will be able to study and analyze the behavior of the attacker, what he is trying to access, so you can harden it, making it stronger on the real system. So this is an illustration. And we come to the end of the chapter. So we talked about the need for firewalls, firewall characteristics, and access policy. We talked about the types of firewalls, packet filtering, stateful inspection, application level, circuit level. We talked about the host-based firewalls and personal-based firewalls. We talked about the intrusion prevention systems, host-based, network-based, distributed, and the Snort Inline. Thank you very much. See you later, inshallah. Be well and protected.